Alright, so this is going to be the solution to the 27th problem in the grind 75. This one is called 0, 1 matrix. This problem was pretty difficult. So basically, given an m by n binary matrix, return the distance of the nearest 0 for each cell. So for example, if we start at this cell in row 0, column 0, it is already a 0, so its distance from the nearest 0 cell is 0. But if we were to go here, the distance to the nearest 0 cell would be 1. If we were to look at this node right here, it would have to travel 2 steps to get to the nearest 0 cell because it's saying adjacent. Um, and adjacent does not mean diagonally adjacent. It has to be next to each other like that. So the approach I tried to do was basically you're at a node and then you want to find the nearest 0 if your current node is not a 0 by spiraling out from it and checking to see if there's 0 values. So that turned out to be very hard to implement as an algorithm. It's kind of weird because you have to go +1 for the row and then +1 for both and then +1 for the column, or sorry, -1 for the row, and this one would be +1 for the column. So it turned out to be very messy. The solution to this is actually very interesting, but it's not something that you would easily come up with if you haven't heard of it before. So the approach is a dynamic programming approach, and we will actually switch over to Paint to get a better understanding of this. So we don't really need to see that bottom right value. It's all right that it's covered. So basically, what dynamic programming is, in a very general sense, is considering we have everything before our current state, how would we just add 1 to it, essentially? What that looks like in this problem is, say we are at this node right here, and we know the distances of every node that is adjacent to it already. So all we have to do is get the minimum of that one to find out what its distance is, and we would just be able to add 1 to it. So basically, that's what we do. We're going to check each node's adjacent node, its up node, its left node, its bottom node, and its right node. We're going to check those for their distances, and then we're going to add 1 to get this one right here. The only issue with that is when we iterate over a matrix, or honestly when we iterate in general, when using a for loop, we can only increment the number we are using to iterate. So I, for example, we do I plus plus. So for matrices, we do I plus plus and j plus plus. And say we start here at 0, 0. Basically what that would look like is if I plus plus is representative of the rows and j plus plus is representative of the columns, we're going to iterate over every row and then every column, going from top to bottom and left to right. So we're going to go like this. And then this one's going to go here, and we're going to go like that. But the thing is, the dynamic programming approach requires us to look at cells whose distances we've already calculated. And if we are going from top to bottom, left to right like this, the cells that come before will be the ones that are towards the top and towards the left. So we will only actually be able to get values from there. So we can do that, but if we don't also start from the bottom and travel from right to left, so go like this and like this, then we might not get the appropriate distance for our cell. So I will give you an example by using this illustration right here. So maybe let's take some of this away. if we get what the distance of this cell is from the closest zero based off of the top cell and the left cell, again, we would be able to do this if we were iterating from left to right, top to bottom, then we would get that its distance is 2, that was 1, 2, and also 2. So then we would say that its distance is 2. But we know that its actual distance from 0, its closest 0, is only 1 away. However, we won't know that unless we look from the bottom and go from right to left. So bottom to top, right to left. So that's why we need to have two sets of 2 for loops. One that goes from top to bottom, left to right, and one that goes from bottom to top, right to left. So let's implement that. Okay, we're going to switch over to the LeetCode window. And let me shrink the window a little bit. Go there. Does that look good? Yes, okay. So first off, what we want to return is actually a matrix with the same dimensions as this. It's just that each index is going to, each element is going to represent the distance from its corresponding elements in the original matrices, its distance from 0, if that makes sense. So, this 1 right here is this 1, and its distance is 2. Okay, so we're just going to create our own matrix. We can just call it result, set it equal to a new matrix. Again, it's going to have the same dimensions as our original, so we're going to give it the same row length and the same column length. All right, and then another thing that I ran into is basically we're going to be getting the values from before. For example, if we're iterating from top to bottom, left to right, then once we start out at 0, 0, we're not going to have some values before. So we're going to have to give it some default value. So I tried to give it integer.maxval, but that yielded an incorrect result because integer.maxval actually was a negative number, like a really large negative number. And so when I tried to get the minimum distance for, say, the left and the top, it would choose that default value because it was negative. So what we're actually going to calculate is the maximum possible distance that a node or a cell could be from a 0. So for example, if we had all 1s here and then a 0 here, it would take 1, 2, 3, 4 steps to get there. So to get from one end of a row to the other, that's row minus 1 steps. So basically it's row minus 1 steps. And then again, to get to the diagonal opposite corner, we'd also have to go 1 minus the columns steps. So we can just do that. Okay, and now we're going to start by doing the top to bottom, left to right for loop. So we're going to say int I is equal to 0. That's going to be represent our rows, and as long as it's less than the row length, and similarly we're going to say for int j is equal to 0, as long as j is less than the column length, and we're going to increment that pointer. First off, we're going to check if the value at our cell in the input matrix is 0. If it's not 0, actually, because they all start, this matrix right here, our result matrix, starts out with zeros in every position. So if it is 0, we just don't need to update it. So we're going to check, we're actually going to create integer top cell, which is going to represent the distance, the top cell's distance to the nearest 0. And first off, again, if we're starting at this 0, 0 cell, we want to make sure that our row at least is one more than our initial row. And if that's the case, then we can take the previous value from matrix. So we can say I minus 1 and then keep the j. So this will be the cell directly above it. And actually, we will not take it from matrix, we'll take it from result, because result has the distances, right? Otherwise, we're going to return max distance as our default value. However, we can be confident that no value will, while a cell in result might contain the value from this if statement right here, it will be given its appropriate value eventually, once we go from bottom to top, right to left. Okay, and we got to do a similar thing here, but we're going to do it with left cell. And we're going to say if we are off of this left side right here. So if we're greater than the farthest left we can go, then we're going to look at the cell to the left and yield that result. Otherwise, we're going to yield the max distance. And then we're actually going to put into result at the appropriate spot. We're going to put into it 1 plus the minimum of these two. So top cell or left cell, whichever distance is smaller. Okay. All right, now we are going to do the same thing, but this time going from bottom to top, right to left. So just gonna copy that over here. Gotta be very careful to change everything appropriately. So bottom is going to start off at the last index, last row index. And we're actually going to say while it's greater than or equal to 0. And we're going to decrement the pointer. Similarly, we want to go to the last column index. We're going to say while it's greater than or equal to 0. Also got to decrement that pointer. If the value in that cell is not equal to 0, then what we're going to do is we're going to look at the bottom cell and the right cell. So first off, we have to make sure that we are greater than, or let's see, actually here should be greater than 0, and that should be greater than 0. In this case, we want to be less than the maximum row length, or not the maximum row length, but the maximum row index. If that's the case, then we know we can go one row down to get our bottom cell and then grab that distance. And similarly, we can do, as long as we are one less than the rightmost column, then we can grab that right cell right there and get its distance. And then what we're going to do is we're not just going to fill in bottom cell and right cell here, we're going to actually compare it to what we have already found by iterating from left to right, top to bottom, because there's already some values there and some of those might be the true minimums. So what this is going to be equal to is actually the math.min of one of those or what's already in place for the results matrix. Okay, and that should be all there is to this problem. I'd just have to return result, and let's just run to make sure there's no syntactical issues. Okay, let's see. Can't find a symbol. Top cell, left cell. Yes, it should be bottom cell and right cell. Okay, let's run. What does it say? Index out of bounds for this right here. Got to put that -1. Okay. All right, what does it say here? Index 1 out of bounds for length 1. Give me 1 second while I figure this issue out. Okay, so it's right here. We're looking at the column, right? So we have to index into the column. So let's run it really quick. Okay, so that has been the solution to 0, 1 matrix, or I guess binary matrix. This has been the 27th problem in the grind 75, and we will conclude our video right here.